Okay, this video is about how to compute productivity. And so what you see in front of you is sort of a completed handout, if you will. What I'm going to do is sort of talk you through where these words came from, and then I'll leave it up to you to probably pause the video and work on it on your own. So basically, productivity is computed as output divided by input. So in the case of Larry's logs here, they're going to produce 240 wood boxes per day using 100 logs. So we're going to take output, we're going to divide it by input, boxes per log, 240 divided by 100, and that's going to give us 2.4 boxes per log. This is a really important thing right here, that you understand that boxes, that's how it is interpreted. So down here I have interpretation. We have 2.4 boxes produced per log. Knowing what you've computed other than 2.4, of course, is important. Down here, I changed it a little bit to labor productivity. So here we're producing 240 wood boxes per day using 100 logs. But each log now requires 3 hours of labor. So now we can compute it such that we interpret it as boxes per labor hour. So again, we're going to have output divided by input, boxes divided by labor hours. So we've got 240 divided by 100 times 3, because that's what I said, each log requires 3 hours of labor. So we have 240 divided by 300, which is 0.8. And so that means that we produce 0.8 boxes per labor hour. The interpretation is basically we have about 80% of a box produced for each labor hour. Down here, Larry has a new situation. He's considering buying from a new supplier, and everything is pretty much the same except for they can produce 260 boxes per labor hour. And in the case of this, we've got 260, so now we're doing everything the same. We've got output divided by input, but we have 260 divided by 100, so we have 2.6 boxes per log. So if we were to go back up and compare that to right up here, we can see we have a little bit more boxes per log, 2.6 versus 2.4. We can also do this in terms of labor productivity. So again, we're going to do it the same way. We're going to have output divided by input. Output's 260 divided by 100 times 3 plus 8. So we end up with 0.844 boxes per log. Now, here I've computed what the change in log productivity is, but I'm going to skip to down here because I've got it written out a little bit better down here. That was a little redundant. So Larry, if he changes to the new supplier, what's the change in log productivity? Well, it's going to be new minus old, so 2.6 minus 2.4. And then the change in labor productivity, again, we've got the it's 0.844 minus 0.800. The next thing we care about in this productivity calculations is the percent change in log productivity. So here we're going to take the new minus the old divided by the old. So we have 2.6 minus 2.4 divided by 2.4, which is going to give us this 0.083. That's the percent change in log productivity, which is the same as down here. This is going to be the percent change in labor productivity. And then again, the interpretation is really important. If we interpret this as log productivity has increased by 8.33%, labor productivity has increased by 5.5%, and the interpretation for which is better or whatever is that the increase in productivity is larger for log productivity than for labor productivity. So this is the basic idea with single factor productivity. Now we're going to move on to multi-factor productivity.